Hi, everyone. I'm Doug Black at Inside HPC. And for today's at HPC podcast industry view, we are speaking with Professor Dieter Kranzlmueller. He is chairman of the board of directors at the Leibniz Supercomputing Centre, that's LRZ or LRZ, in Munich, Germany. Professor, welcome.
Well, thank you very much for having me. I'm a listener of your podcast, so it's a real honor to be here.
Okay, we're thrilled to be with you. So we're speaking about LRZ and a new supercomputer from HPE Cray at the center. But let's start with a look at the overall picture at LRZ, the LRZ mission, and really the key areas you're focused on.
Well, LSC's mission is to provide computing services to science and research. So we are trying to deliver everything that the scientist needs for his or her daily work. And that begins with things like we are running the local scientific network, we are providing storage to many institutions, we're providing computing capabilities, and that's across different levels. So starting from the Munich ecosystem with our excellence universities to the Bavarian, the state of Bavaria's universities. We are also one of the 3 national supercomputing centers in Germany, and we are providing capabilities to Europe. Like at the moment, we are one of the hosting sites for the quantum computer. We've done that since more than 60 years. We were founded in 1962 as a center to run big computers. At that time, computers were still invented locally here, and they were big as large rooms, and it was clear that this cannot be done at the university, so they needed a computing center. Today, we are still building our own computers, and one of them we'll be talking about today, but the model has a bit changed. So for us, we continued also not to do only computers, we also provided computing services, just like a service provider, but specialized to what scientists need. And then in the end, we actually believe we are a partner of digital transformation for science. So the scientists come with their needs, and we try to assemble our tools, our computing capabilities so that they can do whatever they need to do. And that's the picture, what we have today, in a sense.
Okay, so tell us about some of your biggest challenges at LRZ as an organization.
Well, I would mention 2 things. On the one hand, we are on the forefront of technology. So it's very important to stay up to date, to see what's coming, and especially also to have a look into the future. So we are trying new technologies, exploring how they could be used for science. And that's a very interesting, but also a very tough job because technology is developing rapidly. And on the other hand, we also need to make sure that this fits in our budget envelope. So we have challenges, and today's biggest challenge is power, electricity, and cooling in a sense. How do we get the electricity that we need to run these supercomputers, and how can we make sure that we use this electricity in the best possible way? So keyword, energy efficiency. Our belief is we can compute more if we are more energy efficient.
Great. So now, how is the need for AI-driven science impacting your organization? The need for AI plus modeling and simulation.
Well, on the one hand side, we have, of course, lots of demands for AI computing capabilities. And that means we need to provide more AI tools to the users while the building is not growing in a sense. So what we kind of have to make sure is that we get AI as an add-on to our other services. So I'm convinced HPC is not replaced, but it's kind of annotated, extended by AI. And what we want to do is to bring these tools together so that the scientists can use them either simultaneously or one more than the other, and that in changing environments. So we really see AI as an extension of HPC, not only in using it, but also in how we are running our systems.
Okay, so now LRZ is investing in a new supercomputer. Tell us about that.
Well, our new supercomputer, codenamed Blue Lion, is really a system that makes us very excited. That started already when we started planning Blue Lion. We didn't want to just procure another system by kind of providing goods and services and having vendors fill out the sheets. We wanted to do it differently, and what we did was an innovation partnership. So we started by procuring, in the first step, prototype systems. So we got real hands-on experience from different vendors who were competing for our system, and we had the possibility to really explore what it means to try different vendors' technologies. And the second step is then once we had that, we also focused on the applications performance. So one thing I'm very critical about is the top 500 list of supercomputers. I mean, it is very valuable to have these decades of data, of course, but I don't think it reflects today's needs in terms of high performance and AI capabilities. So we were rather focusing on different benchmarks. And again, we used the prototype systems to really find out what is the best possible benchmark for the needs of our users. And the result was that our system was much more focused on HPCG, high performance conjugate gradient, because it reflects much more what the users need. And that's what we want to do. We don't want to build the fastest system. We want to build the best system. And we believe that what we are getting is following that criteria.
Okay, so tell us what does this really mean for LRZ?
What it really means is we get a jump in computing performance. So we expect that the Blue Lion for our application performance is a factor of 30x, which is quite some number. And this 30x helps us really to get forward with the science being done on our system. So we are trying to move the barrier for scientific insight a little bit further. And with the new system, we are confident that this will kind of open new doors and allow us to address some of science's most difficult questions and how we can resolve them with computing, both in HPC and AI.
Okay, so tell us at a capabilities level, what does this really deliver for the center?
So in a sense, Blue Lion is our top of the line tool. It's the tool that we use when other supercomputers, not only in Munich, but in Germany in general, are not suitable for the task. When we need to go beyond what an individual university can deliver. So Blue Lion should provide these capabilities in a sense where we can go beyond what we usually get. And that's why it's important to have really an integrated system where the individual components fulfill the needs and the demands from the using community. And that could be from various fields of science. I mean, we're really starting from astrophysics to zoology. We have a very broad landscape of different uses. And Blue Lion is really a flexible system that allows us to really help each of these scientific domains.
By the way, I love that name, Blue Lion. What is the derivation of that system?
Well, that's a funny story, and it gets back to a discussion with my minister. We did a competition with different names, and the minister didn't like any of these names. So in the end, we said, well, there's one more name, similar like what Steve Jobs always says. And this last name on the list was Blue Lion. And the minister said, well, that's the one that we want to have. And it seems he likes it because we also kind of named our prototype system the cubs, the baby lions, so to say. And kind of we're going around. And of course, a lion is the symbol for Bavaria. So I think it fits nicely into the story.
Are. Great. Okay. So at a more specific level, tell us about the user benefits you expect from Blue Lion.
Well, our goal was always that the system is kind of easy to use. I mean, the predecessor of Blue Lion was a general purpose architecture, which did not have accelerators in the first phase. So we really wanted a system where, in principle, you could use your code from the laptop, put it onto the big system, scale it up, and you can use it. And we saw that already with the predecessing system that users love it. They love the easy way to do these things. Now, today, you need to build a supercomputer with accelerators. There's no way around it. So what we wanted to do is to have these accelerators really nicely integrated into the system so that you can still benefit from the easy to use architecture, but you can also use accelerators if needed. And especially in AI, it's also an aspect from how does the software complement what the hardware is doing in a sense. So we really believe that we have a very flexible system that kind of fits to what users from different domains and also from different qualities. I mean, we have users which are, as we call them, the clickers, which just click on the screen and do the results. But we also have high energy physicists, as I always say, who know every bit and know how to mingle this bit. And the architecture should be able to make both of them happy in a sense on both sides of the spectrum.
Okay. Yeah, looking at the architecture, why was the HPE Cray GX architecture the right choice? And talk to us a little bit about HPE as your partner.
So we knew HPE from some smaller systems, and it did not come as a surprise that they were bidding in a process in a sense. What we were looking for is a hot water cooled system, and that was an interesting aspect for HPE also to go that direction. So the Cray GX architecture that we're talking here about is one system that takes this step forward with highly energy efficient cooling mechanisms, and really also making sure that we're doing this again very energy efficient system with not only general purpose compute cores, but also with accelerators. So in a sense, it meant that we need, and I've said this often enough, we don't need somebody to sell us a system. What we need is a partner that is interested to work on the challenges together with us in order to bring a system on the floor that is really most suitable to what our users need. And we believe that HPE is the right partner. What we see so far in preparing for the system, they have understood that we are not just a consumer-producer relationship, we want a partnership, and that's what it has played out so far.
Okay, and tell us about your silicon partner and why they were selected.
Well, the silicon partner is in a sense also part of the entire concept in a sense, as we were looking for somebody that can bring together CPUs and accelerators at the same point. And what we are using for the system is NVIDIA with their next generation system. So again, we have kind of a very strong partner in here that delivers both application performance on the CPU, but as we know from NVIDIA, has a strong foot into acceleration and how their GPUs can be used. So the partnership here is, again, we want to bring this forward with the best possible technology that is there.
Okay, and will Blue Lion have a role in quantum exploration at LRZ?
Absolutely, absolutely. Quantum is one of our key aspects here. We see quantum not as a standalone technology, but we have started in 21 with our Quantum Integration Center. And the idea was really, can we use quantum as an accelerator for supercomputers? So again, the idea of integrating both things is essential for us. So our approach is the supercomputer will continue to do most of the things. So the supercomputer is a fantastic machine. But once the supercomputer finds a place in the code where we could have quantum advantage, then it hands over control to the quantum computer. So we spent some time, some effort to integrate both things. And about a year ago, we submitted the first job from the supercomputer to the quantum computer and returned the results. And this is also what we will be doing with Blue Lion. So Blue Lion is also an entry point for the quantum computers that we have at LRZ.
Okay, and earlier in your opening remarks, you mentioned energy efficiency. Tell us about the energy considerations, implications of Blue Lion.
So one of the things, and I should have talked about that in the beginning, we are buying a system not by just saying this is the money for buying the hardware. What we're doing is we're providing total cost of ownership. So the budget we have is the system hardware plus the operating costs during the runtime. That means you need to optimize the energy consumption in order to make sure you have a big enough system to win the competition. And having these most energy efficient system also means we can build a bigger system. So energy is the key question here. We want to have more computing power, and we get that by being more energy efficient.
Okay. Now, looking forward, what's coming up next in the future for LRZ?
That is the very interesting question in a sense. And in fact, whenever we sign a contract for one system, we start working on the next system. So we are already developing strategies on how to get to the post Blue Lion system, so to say. And I think many of the things that I told you about the vision and the mission that we are doing will remain constant, but what will change is the technology available for that. You mentioned quantum as one thing. I could imagine that maybe the system afterwards will really have a much more tight integration with quantum. I could also see different technologies, like what we just recently bought was a photonic system. Yeah? So we have a computer that computes with light, and I could also see this technology being part of the next system afterwards. So whenever we put the system on the floor, it's not kind of the end of the story, it's an intermediate step, and that makes it more interesting to see what comes afterwards and also to take a look into the future. So my horizon in a sense is I've started working on a system that will be coming in the 2030s, and that will all probably be running until the 2035. And that is an interesting perspective, especially if you live in an area like technology like we do.
All right, very good and very interesting. We've been with Professor Dieter Kranzlmueller at LRZ. Thanks so much for your time.
Well, thank you. It was a pleasure.